This is your Daily 10. Calculator, Video 8. Make sure you pause the video and attempt the question before you watch the solution. Here's your first question. So what we need to do here is to write down and show which of these inequalities is represented by the diagram there. Because this one here is a coloured in circle, that means that we need values that are bigger than or equal, the equal bit because we've got the coloured in circle. This one on this side represents everything less than, it's got an open dot, not coloured in. So we need everything that is bigger than or equal to 7, but less than 6. So it would be this one here that we select as our answer. Here's your next question. Now for this one we're given some relative frequencies, also potentially known as probabilities, of different colours being spun when we do a spinner. Now it says that the spinner has been spun 400 times. We can use these relative frequencies to actually work out how many times it landed on red, blue and green. All we need to do is to take each of the numbers, each of the relative frequencies, and multiply it by 400. So for red, we would have 0.35 times 400, so 140. Blue is 0.5 times 500, that's 200. And 0.15 times 400, that would give us 60. And that would be the number of times it landed on green. So the question then says, how many more times did it land on red than green? So it's just the difference between 140 and 60. So 140, take away 60, that means it was 80 times more. Here's your next question. So here we're solving simultaneous equations. The first thing you need to do, and this is a personal preference because I know other people teach this in slightly different ways, is I always try and do this so that I make the second thing, the second letter, y in this case, the same in both. So in order to do that, what I'm going to do is actually multiply this bottom equation by 2. So if I times this bottom equation by 2, that would give me 3x times 2, so 6x, minus 2y equals, I'm timesing everything by 2, so 26. I'm now just going to remove that equation so I don't get confused by it later. At this point we can then use the little acronym DAS. Now this only works if you use the second letter and make that the same in both. It doesn't work making the first letter the same. So because we're looking at this, plus and a minus, so the symbols are different, so we are going to add these two equations together. 3x plus 6x is 9x. The plus 2y and minus 2y cancel each other out. 10 plus 26 is 36. So we've got that 9x equals 36, so dividing by 9 gives us that x is equal to 4. So we can put that down at the bottom. It's given us the clue here that we need to also work out what y is. Well, in order to do that, I take one of the equations, doesn't matter which one, and I substitute the x equals 4 back into that. So I'm going to use this equation up at the top because it's got smaller numbers, so I think this one might be easier. And all I'm going to do is replace this x with a 4. So 3 times 4, replacing the 3x, plus 2y, that's what I'm trying to find out, is equal to 10. So here we get 3 times 4, which is 12, plus 2y equals 10. I'd then need to take 12 away from both sides to leave me with 2y equals minus 2, because I've done 10 take away 12. So dividing by 2 means that y must equal minus 1. So I can put that onto my answer line at the bottom. Here's your final question for this video. Here we're being asked to find the arc length, so the curved length here of the two sectors. So what we need to do is to actually work out both the small and the larger sector and the arc. If it was the full circle, it would be the circumference of the circle. So that would be pi times diameter. Now, because we're only looking at a part of the circle, we only need a fraction of this. So if we start with a smaller one, because the angle here is 120, we are effectively looking for 120 out of 360. Because remember, a full circle, full turn, is 360 degrees, multiplied by pi times the diameter. Now this, for the small arc sector, represents the radius. So if the radius is 4, the diameter must be 8. So the diameter here is 8. So I'd then take my calculator, should I say, and I would type that in. So 120 over 360 times by pi. Oops. Helps if you actually look what you're typing. So times by pi times by 8. If we change it into a decimal, gives us an answer of 8.3775. So 8.3775. I'm not going to round it at that point because we always round fully at the end of a question. I now need to do the exact same for the large sector. So again, because it's 120 degrees, it's 120 over 360 times pi times by. Now the diameter, remember, for this large sector, well, the radius here is 5, so the diameter must be 10. So again, I take my calculator, and this time I need to do 120 over 360 times by pi times by 10, and again change it into a decimal, so 10.4719. Of course, there's more numbers after that. Because I'm looking for the difference, so how much bigger this one is than this, I would then have to do, as my final step, 10.4719 take away 8.3775, which if you use your calculator, I'm going to do 10.4719 take away 8.3775. We get an answer of 2.0944. Just check, the question does say to 1 decimal place, so that is going to give us an answer of 2.1.